to look at the last part of this very section, application of surd. Last time we discussed on 30° and 60° using an equilateral triangle. And in that very discussion, we were able to determine the ratio for sine, cosine, and tangent. But this time around, I want to look at angle 45°. And we are still going to determine sine, cosine, and tangent. Okay, given an isosceles right angle triangle, ABC, given an isosceles right angle triangle, ABC. And we already know what is an isosceles triangle. We already know what is an isosceles triangle. It means that two sides are equal, two sides are equal. Okay? And AB is equal big C. And is equal 1 unit. Please take note, is equal 1 unit. AB is equal big C. And we don't know XC. We don't know XC. Therefore, let me use X to represent that very part. Now, what can I do now to now determine X? And we have sides. We are dealing with sides. Please take note, whenever we have right angle triangle and we are dealing with sides, okay, we simply use Pythagoras theorem. But if you are dealing with angle, we use SOHCAHTOA. Please take note of that. If you are dealing with angle, use SOHCAHTOA. If you are dealing with side, use Pythagoras theorem, meaning the one that has to do with right angle triangle. If here is 90, here will be what? 45. 45°, here will be 45°. Okay? It means that if I represent here with 90 now, and here is 45, here is 45, if I have them up, therefore I will have 180°. It means that 45 plus 45 plus 90, it will give me 180°. Don't forget that angle in a triangle, sum of angle in a triangle, they are equal 180°. Okay? Now for this now, since I have 45 here, I have 45 here, let me now determine x. Okay? Now for the x, it has to do with side. I will use Pythagoras. Remember I told you before, if you are dealing with side, use Pythagoras. If you are dealing with angle, use SOHCAHTOA. Now, since I'm dealing with side, let me use Pythagoras. And according to Pythagoras, it simply states that the square on the hypotenuse is equal to the sum of the square on the other two sides. Now, which one is the hypotenuse? AC is the hypotenuse. AC is the hypotenuse. It simply means that the square of AC is equal to the sum of the square on the other two sides. I can decide to take here first, AP first. Okay, the sum of it, okay, of this one and this become this very one. Okay, become this very one. This is what I have. Okay, now I can still continue. I can represent them now. Let me represent them. For AC, I have S squared. For AC, I have S squared. While for the AB, I have 1 squared. And while for the big C, I have 1 squared. Now, what can I do again? I need to, when I square this one, I will have 1. When I square this one, I will have 1. Okay, what can I do? You make that 1 plus 1 is equal to 1 plus 1. For this one here, it simply means 1 plus 1 is equal to. Okay, let us now see what we need to get at the end. You mean that S squared equal to, that's what I mean. 1 plus 1, 1 square is 1, 1 square is 1. Okay, when I add them up, I will have 2. Okay, now we're asked to look for x, not s squared. Okay, now we have s squared here. It means that we can square root both sides so that we can determine the value for x. It means that the square root on x, please don't forget, for s squared, if I get the square root on it, this square root will kill this, I will be left with x. Okay, I will also get the square root on 2, I will have the square root of 2. It means that for here now, this very part, x here, I have the square root of 2. Now, what will not determine the ratio for sine, cosine, and tangent? Don't forget, in the other one we discussed, the one that has to do with 60° and 30°, and we still determine the ratio for sine, cosine, and tangent. Okay, for this one of 45, we still do the same thing. Okay, now what can we do for this very one? It means that I'll still determine sine, cosine, and tangent. And in this very one, I'm now going to deal with angle, none of that side. Therefore, I will use SOHCAHTOA. Okay, I want to determine angle, that side 45° cos 45°, and also tan 45°. Okay, using SOHCAHTOA. Okay, let us now see now. I want to use SOHCAHTOA, using SOHCAHTOA. Okay, SOHCAHTOA. Now, what do we really mean by this? using SOHCAHTOA. This one simply means opposite over hypotenuse. That is the one that has to do with sine. It means that for this one now, I want to determine the one for sine. Okay, opposite over hypotenuse. This one is the hypotenuse, HC, and which one is the opposite? Opposite. Okay, depending on the angle I want to deal with. Since we have the same angle, okay, let me use this one. Wherever this one fits, become opposite. It means that here is going to be opposite, AB is going to be opposite. Therefore, now for that, now we now have opposite over hypotenuse. That is to say 1 over root 2. And we have a surd at the denominator. Simply rationalize. It simply means that 1 over 2, 1 over 2 rationalize it to become 2 all over 2. Okay, when you multiply numerator, I will have root 2. Multiply this one become root 4. And don't forget that 4 is a perfect square. I will have root 2 over 2. Okay, it means that for this one, I'm going to have root 2 over 2. Okay, that is the ratio for sine, 45 degree. I will also determine the one for cos 45 degree, and cos has to do with adjacent over hypotenuse. Since here is already opposite, it means that here will now become my adjacent. That is still 1 over root 2. Okay, but this one is still 1 over root 2. Therefore, remember that we still have a surd at the denominator. We cannot take it like this. I have to also rationalize. I will still have the same ratio. It means that cos 45 degree and sine 45 degree, they have the same ratio. Okay, now let me now look at the one for tan 45 degree. Tan 45 degree. Okay, for tan 45 degree, it has to do with what? Opposite to adjacent. Now, I'm dealing with this angle it's facing here. Here is opposite, here is my adjacent. Okay, adjacent, they're opposites. That here is opposite, here is of course, become opposite over adjacent. That is, you see, 1 over 1. 1 over 1, don't forget, 1 divided 1, I will have 1. Therefore, tan 45 degree is 1. This is how we determine the ratio for sine, cosine, and tangent using isosceles right angle triangle. Of course, this one we have done so far. I hope we understand. We understand very well. Okay, at this point, I'm going to conclude. I'm going to conclude at this very point. We want to now go to calculation. We want to use all these this derivation, this angle, these ratios to determine that we want to use them to solve problem. We want to use them to solve problem. We are able to determine their ratios. Okay, we cannot use them for problem. Thank you very much for joining me on this very platform, JB Jungle Online Mathematics. Don't forget to subscribe to my YouTube channel, Mathematics Science Mega Tutorial. All the best.